All right, my name is Jeffrey. I'm here to talk to you about orchestrating tightly coupled HPC workload in Rescale using Nextflow. So first, let's start talking about what's the state of R right now. For Rescale's customer, mostly exists in pharmaceutical, aerospaces, automotive. So when we survey our customer bases, the standard way of doing automation today is to script something against the Slurm or PBS or something like that. So this solution works, but there's definitely drawback to that. So the scripts are custom built, they're difficult to maintain other than the person who wrote it. And anybody who wrote your own script probably should expect the same thing. And it's tied to a very specific architecture. So if you write something for Slurm, you won't be able to use it against AWS. And when you get to the beyond the basic stuff, we try to implement parallel execution, dependency logic, it gets very difficult. It's just very difficult for a sequential scripting language like a bash shell to be able to implement all the complex logic needed in today's modern workflow. So companies are moving towards having a workflow solution. And some of the key benefits they're looking to get out of that, including the reusable component. They want to write small components, they want to compose them together. They don't have to write everything from ground up. They want to make it to be portable across different service providers. And they want to simplify the logic of doing parallel execution and things like that. So how do we make this happen? And this is what Nextflow has been an instrumental tool in driving this transformation. So the Nextflow obviously has a lot of features, but two of most outstanding features that help with the transformation from scripts to workflow. One is the separation of code and environment. When you use the executor to abstract your execution environment, you can now connect to different environments through simple interfaces, and you don't have to worry so much about the execution logic. You can focus on the research logic that you guys are good at. So this enables the scientists to really focus on really doing best and improve their efficiency. The second part of that is integration with multiple tools. And when you can wrap all the different tools under a process in Nextflow, and then you can start mix and match them. So you're not necessarily tied to what you are already accustomed to have. It makes it much easier to use open source libraries to get the best of in-class software to help accelerate your innovation. So this two particular capability, I think, is most resonating with all the customers that I talk to. So a big word about Rescale in case you guys don't know who's Rescale. So Rescale is a HPC as a service company. So what do? We integrate all the components you need to run HPC into a simple packages that you can trigger over API. So here on the top, you can see all the software we integrate with is already configured, optimizing our software catalog. On the bottom are all the hardware vendors, service vendor we integrate with. On the left side is beyond hardware and software, there's actually a lot of supporting stuff you still need to configure, license, monitoring, and workflow, all the things that we are integrating into the platform. And on the right side, you got all the IT stuff. Billings, budgeting. It's probably very boring for everybody in this room, but if I talk to some IT directors, they really get kicked out of it. And if you imagine, if you know all the way they have imagined to control and monitor your behavior, that will make George Orwell's 1985 look like a child play. So, but they are the people you have to deal with. So whether you like it or not, they are going to be a key part of your organization. So what Rescale does is we're taking the hardware and the software and the environment and the ITs, we just combine them into a simple, easy-to-use packages that you can run over API. So if you combine the power of Nextflow and the Rescale together, here's what you're going to be getting on the right side. So on the bottom, here's all the major CSP and some of the specialty CSP that we interface with. If you want a lot of GPUs, you can go to CoreWeaves. If you want to do your high-performance computing without the guilt of killing the planet, you can use Responsible Compute. It's a specialty CSP based out of Iceland. Electricity comes from the volcano, so it's very clean. And in the middle, what we have is the control plane that connects all the things together. On the top, we have recently built two executors. One is called HPC executor, the other one called HTC executor. And the reason we build two executors is like give you access to two different purposely built architecture. If you need to run very high performance workload using VMs, using MPI interfaces, you will use HPC. If you want to run container-based orchestration, you want to focus on your throughput, you want to scale to thousands of nodes, then you will use HTC. What makes this unique is that both HPC and HTC can talk to each other through a shared storage. And in this particular case, we're using some raster file system as the medium of exchange, so that you can leverage the same share file system to exchange data between the VM-based orchestration and a container-based orchestration. And on the top, you have Nextflow, become the orchestration engine, leveraging executors and processes to be able to orchestrate the entire workflow end-to-end. So for someone who is building a computational pipeline, you learn Nextflow, you learn its Groovy languages, and you program all the executors, and then leave all the billing control and CSV access to Rescale. To give an example of how this is being used, so I have a two computation pipeline has been deployed on the production. The first one is what we primarily use to able to solve the resource provisioning issue. So there are two jobs here. And the first job is try to do the mashing in a simulation. The second job is to do a frequency sweep. The first job, you need a very, very large VM, with a lot of memories, and the mashing has to be done in a single node. So you can't just stack up the memories through a cluster. And without the computational pipeline, what ends up happening is we have to use a really big machine with a lot of memory for everything, and leading just to a lot of waste resources in the second step of that, which you can actually, by looking at the result of the machine, deciding what's the right memory requirement for that, and use maybe a smaller hardware for it. And the list can be calculated dynamically. So in these particular cases, we can save somewhere between 30 to 40% of hardware cost if you use computation pipeline to break into two steps of that, and the provision of hardware based on the result of the first jobs. The other example of using a computational pipeline is able to connect all the architecture, the tools into a plug-and-play packages, and you can start swapping them out and experiment which one works best for you. So in a machine learning workflow that we're building for our customers, we have to first run thousands of simulations. Then we gather data, we aggregate data, then it passes through some kind of machine learning training processes, and finally, it will come to a model you can deploy, and you can use it for inference services. And all of them has very different hardware requirement, but it is in a single pipeline. So for simulations, you need a lot of VMs. For machine learning model training, you actually need to find GPUs that can really get the job done. But when you get to inference services, probably commodity hardware will do just fine. In addition to the different hardware requirements, the software are also different. Sometimes you already have an in-house software that you already licensed for, but maybe they are kind of outdated because they have been the dominant player in the market, and the dominant player tend to get a little complacent. So there's a lot of open source software out there that can really take advantage of latest thinking and give you that kind of a boost in your productivity. So what you can do in the case of, for example, machine learning, you have the TensorFlow and the PyTorch from the Facebook and from Google, that are big companies. But there's also startup like a Navasto and Media Modulus that's really catching up and focusing on solving AI-aware physics problem. So instead of being tied to a specific software and hardware within the computational pipeline in Nextflow, you can basically swap them out and see whichever one works for you. I think this is a key reason that the life science has seen a lot of progress in the last decade, is the ability to be able to leverage the open source software and get to the best part of innovation. So this is a pretty short presentation. Mainly here, I want to just tell you a little bit about Rescale and how Rescale and Nextflow are working together to accelerate computation, workflow transformation in some of the more traditional industries. And if you want to find out more about that, check out rescale.com and let us know if you have any questions.
Thank you for the talk. So we have a question. Are the executors public, the Nextflow executors?
They are in beta stages. We plan to publish onto the Nextflow repos pretty soon.
Okay, thank you very much.
Thank you.